Hello everyone, welcome to this video by Simplilearn. Today we are diving into the comprehensive SQL Full Course for 2024. So before we jump into the course content, let's quickly address what SQL is and why it is crucial for 2024. SQL, or Structured Query Language, is the standard language for managing and manipulating relational databases. So in today's data-driven world, SQL remains an essential skill for anyone working with data. As we move further into 2024, the demand for SQL skills continues to grow. With the explosion of big data, cloud computing, and data-driven decision-making, SQL importance has only increased. It is used across industries for everything from business intelligence and analytics to powering web application and managing vast datasets. Whether you are a data analyst, software developer, or business professional, understanding SQL can significantly boost your career prospects.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
And if you want to become SQL certified, so here is a quick info for you. Try SQL Certification Course by Simplilearn. This SQL certification course gives you all the information you need to successfully start working with SQL databases and make use of the database in your application. Learn how to correctly structure your database, author efficient SQL statement and clauses, and manage your database for scalable growth. So this course is open to anyone interested in learning SQL. No prior experience in programming or database is required. It is ideal for beginners and those looking to enhance their database management skill. So check out the course link from the description box below and the pinned comment. So without any further ado, let's get started. The agenda of SQL Full Course is: what is SQL? Features of SQL. Moving forward, we will see what is ER diagram, and after that we will learn types of SQL commands. So after covering all these, we will learn installation of MySQL, then MySQL built-in functions, group by function in SQL, and after that joins in SQL, after that triggers in SQL, and the following we will cover views in SQL, and the last we have top 5 SQL interview questions. So without any further ado, let's get started.
In this session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand various SQL commands on MySQL Server. Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use Structured Query Language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top, you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here, each row represents a record or a tuple. So you have the player ID, which is 103 here, the name of the player is Daniel, he is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records, and do a lot of other tasks.
Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft, and it doesn't require much coding to manage databases.
Now you may be thinking, how can someone with no prior experience possibly land a data analyst role? And I get it. The field of data analysis is competitive, and many employers require years of experience or advanced degrees. But here is the thing. It's not impossible. With the right mindset, strategies, and determination, you can absolutely crack into a data analyst role, even as a fresher. So let's dive into what data analyst is. After that, we will see some practical steps and strategies that you can start implementing today to increase your chance of breaking into the data analyst field. So, what is data analytics? To learn about data analysis, you must first know what data analytics is. The term data analytics refers to a group of quantitative and qualitative methods for drawing important conclusions from data, to extract numerous patterns, interaction, connection, and other significant insights from it. Data science entails several steps including gathering data and classifying. So what does data analysts do? On a huge dataset, data analysts gather, analyze, and run statistical studies to glean insights and spot trends. They use various methods and tools to transform complicated data into useful insights. They therefore provide insightful data that enables businesses to make informed decisions. And this is the answer of question, what data analysts do. So moving forward, let's jump into roles and responsibilities of a data analyst. The roles and responsibilities of a data analyst often consist of the following. The first one is create and manage databases and data system, fixing coding mistakes and other data related problems as necessary. The second one is using both primary and secondary sources for data mining. The third one is rearranging data in a way that both individuals and machine can understand. The fourth one is create documentation that clarifies the data analyst process for stakeholder. So now let's jump into how to become a data analyst with no experience, steps and strategies. So becoming a data analyst without prior experience can be challenging but achievable goal. So here is a detailed guide on how to break into the field of data analysis from scratch. So the first one is master the basics. Data analysts need a mix of technical and soft skills. Start by learning the basics of statistics and mathematics. So key topics are descriptive statistics. Learn measures of central tendency, mean, median, mode, measures of variability, range, variance, and standard deviation, and data distribution, like normal distribution and skewness and kurtosis. The second is inferential stat. Understanding hypothesis testing, confidence intervals, p-values, and statistical significance. The third one is probability theory. Basic probability concept, conditional probability, and Bayes theorems, and many more. The fourth point is linear algebra and calculus. Fundamental concept that underpin many statistical algorithms. So you guys can learn these topics from our Simplilearn YouTube channel where each topic is explained in depth by our experts. The second point is programming languages and Python. In Python, learn the basic syntax, data types, and control structures like loops and condition. The second one is libraries for data analysis like NumPy, Pandas, and Matplotlib for data manipulation and visualization. The third one is library for statistical analysis like SciPy and stat models for performing statistical tests and modeling. And in R, like basic syntax like data types and structures. Data manipulation like dplyr, tidyr. The third point is statistical analysis, Bayes R function, and package like ggplot2 for data visualization. So you guys can learn these topics from our Simplilearn YouTube channel where each topic is explained in depth by our expert. The third point is data visualization and reporting. So in this, we have first Tableau, creating and customizing various charts and types like bar charts, line graphs, scatter plots. The second is building interactive dashboards and stories. The third one is connecting to different data sources and data blending. The second one, we have Power BI, data modeling and creating relationship between data sets. The second point is designing reports with visuals, filters, and slicers. The third point is using DAX, data analysis expressions, for advanced calculation. In this category, third, we have Excel. So in this, you can learn advanced formulas like VLOOKUP, HLOOKUP, index, match, and arrays formulas. The second is pivot tables, summarizing, analyzing, and visualizing data. The third is data visualization, creating and formatting charts, sparklines, and conditional formatting. So you guys can learn these topics from our Simplilearn's YouTube channel, where each topic is explained in depth by our expert, or you can go through their official document websites. In Master the Basics, the last point is SQL database and the key concept. The key concept are basic SQL commands. Select, from, where, join, group by, having, or order by. Second is database design, understanding tables, relationships, and normalization. The third is advanced SQL, subqueries, window function, and common table expression, CTs. The fourth one is database management, connecting to a database, writing optimized queries, and understanding the indexes. So you guys can learn these topics from our Simplilearn's YouTube channel, where we have SQL playlists covering each topic that is explained in depth by our expert. The second point is work on your personal project. Applying your new skills to real-world problems is a great way to gain experience. So here are some projects ideas to help you get started. The first one is personal project, public data analysis. Choose a public data set that interests you and perform a comprehensive analysis. For example, analyzing COVID-19 trends over time, predicting house prices, or studying climate change impacts. The second is Kaggle competition. Kaggle is a fantastic platform where you can participate in data science competition. These competitions provide real-world data and problems to solve. For example, predicting customer churn, classifying images, or creating models to improve sales forecasting. The third one is build a dashboard. Create an interactive dashboard using tools like Tableau or Power BI to visualize data insights. For example, a dashboard tracking global financial market or visualizing crime rates in different cities. The third point is get certified. While certification won't replace real-world experience, they can be valuable additional to your resume. So there are numerous data analyst certification available online, such as the Google Data Analytics Certificate, the Data Analyst Program by Simplilearn. This Data Analyst course by Simplilearn in collaboration with IBM will transform you into a data analytics expert. In this course, you will learn the latest analytics tools and techniques, how to work with SQL, the languages of R and Python, the art of creating data visualization, and how to apply stat and predictive analytics in the business environment. These certifications not only provide you with the solid foundation, but also show potential employers your commitment to learning and growing in the field. The fourth point is build a portfolio. One of the best ways to showcase your skills to potential employers is by building a portfolio. This can include personal projects, data analysis on real-world dataset, or even Kaggle competition. The key here is to demonstrate your ability to apply what you have learned to real-world problems. Don't worry if you don't have access to fancy dataset or tools. There are plenty of publicly available dataset on sites like Kaggle or even government website. You guys can make a portfolio like this. So this is an example of one portfolio. So you can distribute your projects like this, or you can take help from this. Okay. The next point is networking and mentorship. Connect with professionals in the field through LinkedIn, local meetups, or professional association. Look for a mentor who can provide guidance, feedback on your projects, and potentially help you with the job referrals. Networking can be invaluable in learning about unadvertised job openings or internship. The next point is internship. Apply for entry-level position or internship. Look for job titles like junior data analyst, data technicians, or analytics assistant. Look for opportunities in local community. Reach out to startups or non-profits, or even consider offering your services for free initially. Even customer service or administrator roles that involves data entry or reporting can serve as stepping stones, giving you practical experience with data. The seventh point is prepare for interviews. Be ready to discuss your projects, how you approach problems, and what you have learned. You should also be prepared for technical interviews that may test your knowledge of stat, programming, and data analysis techniques. You can refer to Simplilearn's video on data analysis interview question and answer on YouTube. So to sum it up, master the basics, build a portfolio, get certified, get experience through internship and freelancing, network like crazy, and never stop learning.
So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, A school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of year diagram, and get it cross-checked by the school authorities. As the school authorities approve the year diagram, the database engineers would carry further implementation. Let's have a view of an year diagram. The following diagram showcases two entities, student and course, and the relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students and a student can opt for more than one course. Here, student is the entity and it possesses the attributes that is student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of year diagram. Let us see why it has been so popular. The logical structure of the database provided by year diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. Year diagram is a GUI representation of the logical structure of a database, which gives a better understanding of the information to be stored in a database. Database designers can use year diagrams as a blueprint, which reduces complexity and helps them save time to build databases quickly. Year diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in year diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity, a dashed oval represents a derived attribute, a diamond symbol represents a relationship among entities, double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of year diagram. There are three main components of year diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of year diagram, starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an year diagram. Let's understand this with the help of an year diagram. Here, both student and course are in rectangular shape and are called entities, and they represent their relationship study in a diamond shape. Let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in year diagram. In the example below, the school is a strong entity because it has a primary key attribute, school number. Unlike the school, the classroom is a weak entity because it does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name, and roll number are called its attributes. Let's see our first classification under attribute, that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number, and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now let's have a look at multi-valued attribute. An attribute that can process more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. When a single element of an entity is associated with a single element of another entity, this is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, a customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects, and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram. Make sure your ER diagram supports all the data provided to design the database. Make effective use of colors to highlight key areas in your diagrams.
There are mainly 4 types of SQL commands. So first we have data definition language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2 and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2 and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp and others. Then we have string data type, which includes char, this varchar and text. Finally, we have binary data types, and binary data types have binary, var binary and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division and modulus. Then we have some logical operators like all, and, any, or, between, exists and so on. Finally, we have some comparison operators such as equal to, not equal to, this greater than, less than, greater than equal to or less than equal to, not less than or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types and operators that we just learned.
In this session, we will learn how to install MySQL Workbench and then we will run some commands. Firstly, we will visit the official Oracle website, that is mysql.com, and now we will move to the downloads page. Now scroll down and click on MySQL GPL downloads. Now under community downloads, click on MySQL installer for Windows. The current versions are available to download. I will choose this installer and click the download button. Now here just click on no thanks, just start my download. Once the installer has downloaded, open it. You may be prompted for permission. Click yes. This opens the installer. You will be asked to choose the setup type. We will go with custom. Click next. Now you have to select the products you want to install. We will install only the MySQL Server, MySQL Shell and the MySQL Workbench. Expand MySQL servers by double clicking on it. And choose the version you want to install and click on this arrow. Now you have to do the same thing for applications. Expand applications and choose the MySQL Workbench version you want to install and click on the arrow. And we'll do the same thing for MySQL Shell. We'll choose the latest version, click on the arrow. So these are the products that have to be installed in a system. Now we'll click next. I'll click execute to download and install the server. This may take a while depending on your internet speed. As the download is completed, click next. Now you'll see the product configuration. Click next. Now we'll configure our SQL Server instance. Here we will go with the default settings and click next. And under authentication, select use strong password encryption for authentication, which is recommended, and click on next. Now here set the password for your root user. By the way, root is the default user. This user will have access to everything. I will set my password. Now I will click on next. And here also we'll keep the default settings. and click on Next. Now, to apply configuration, we will execute the process. Once all the configuration steps are complete, click Finish. Now you will see the installation is complete. It will launch MySQL Workbench and MySQL Shell after clicking on Finish. Now the Shell and Workbench has started. Now we will connect by clicking on the root user. It will ask for a password. Enter the password and it will connect successfully. The workbench has started. Now we'll just connect the server. So first we'll open command prompt. Now we'll reach the path where MySQL files are present. We'll go into this PC, local disk C, program files, MySQL, MySQL Server 8.0, bin. And now we'll copy this path. Now we'll open the command prompt and write a command cd space and paste the link and press enter. Now we'll write another command that will be MySQL -u space root -p and press enter. Now it will ask for your password. Just enter the password and press enter. Now the server has started and now we'll see some commands in MySQL Workbench. First we will open MySQL Workbench. Now we'll click on the local instance MySQL AT and enter the password to connect to the local host. The MySQL Workbench has started. Now we will see some commands. The first command we will see is show databases. Show databases semicolon, and now we will select the whole command and click on this execute button, and here we will see the result in the result grid. These are the databases that are stored already in the database. Now there are 4 databases, that is Information Schema, MySQL, Performance Schema and SYS. Now we will select one of the database. We will use MySQL. Now we have selected the MySQL database, and now in this database we will see which tables are stored in this MySQL database. To see that, we will run a command show tables. We'll select the command and click on the execute button. These are the tables that are stored in this MySQL database, that is columns, underscore prive, component, DB and much more.
Now let me go ahead and open my MySQL Workbench. So in the search bar I'll search for MySQL Workbench. You can see I'm using the 8.0 version. I'll click on it and here it says welcome to MySQL Workbench, and below under connections you can see I have already created a connection which says local instance. Then you have the root, the local host and the port number. Let me click on it. You can see the service, the username is root, and I'll enter my password and hit OK. Now this will open the SQL editor. So this is how the MySQL Workbench looks like. Here we learn some of the basic SQL commands. So first, let me show you the databases that are already present. So the command is show databases. You can hit tab to autocomplete. I'll use a semicolon. I'll select this, and here on the top you can see the execute button. So if I run this, below you can see the output. It says show databases, 7 rows are returned, which means currently there are 7 databases. You can see the names. Alright, now let's say I want to see the tables that are present inside this database called world. So I'll use the command use world, which is the database name. Now let me run it. So currently I'm using the world database. So to display the tables that are present in the world database, I can use the show command and write show tables. Give a semicolon, and I'll hit Control Enter this time to run it. Alright, so you can see the tables that are present inside this world database. So we have 3 tables in total: city, country, and country language. Now if you are to see the rows that are present in one of the tables, you can use the select command. So I'll write select star, which basically means I want to display all the columns. So star here means to display all the columns. Then I'll write my from the table name, that is city. So this command is going to display me all the rows that are present inside the city table. So if I hit Control Enter, alright, you can see the message here. It says 1000 rows were returned, which means there were total 1000 records present inside the city table. So here you can see there's an ID column, a name column, this country code, district, and population. Alright. Similarly, you can check the structure of the table by using the describe command. So I'll write describe, and then I'll give the table name, that is city. Now let's just run it. There you go. The field shows the column names. So we have ID, name, country code, district, population. Type here shows the data type of each of the columns. So district is character 20, ID is an integer, population is also integer. Null says yes or no, which means if no, then there are no null values. If it's yes, which means there are null values in your table. Key here represents whether you have any primary key or foreign key, and these are some extra information. Now let's learn how to create a table in MySQL. So I'll use the create table command for this, and before that let me create a database, and I'll name it as SQL intro. So the command is create database, and I'll give my database name, that is SQL_intro. Let me give a semicolon and hit Control Enter. So you can see I have created a new database. Now if I run this command, that is show databases, you can see this newly created database, that is SQL intro. If I scroll down, there you go, you can see the name here, SQL intro. Okay, now within this database we'll create a table called employee details. Now this will have the details of some employees. So let me first show you how to create a table that will be present inside the SQL intro database. So I'll use the command create table, and then I'll give my table name, that is going to be employee_details. Next, the syntax is to give the column names. So my first column would be the name column, which is basically the employee name, followed by the data type for this column. Since name is a text column, so I'll use varchar, and I'll give a value of 25. So it can hold only 25 characters. Okay. Next, I also want the age of the employee. Now age is always an integer, so I'll give int. Okay. Then we can have the gender of the employee. So gender can be represented as F or M, F for female and M for male. So I'm using the char data type or character data type, and I'll give the value as 1. Then let's have the date of join or DOJ, and this is going to be of data type date. Alright. Next, we'll have the city name, that is the city to which the employee belongs to. So again, this is going to be varchar 15. Finally, we'll have a salary column, and salary we'll keep it as float, since salary can be in decimal numbers as well. Now I'll give a semicolon. Alright, so let me just quickly run through it. So first I wrote my create command, then the table, which is also a keyword, followed by the table name, which is employee details here, and then we gave the column names such as name, age, this gender, date of join, city, and salary. For each of the columns, we also give the data type. Alright, so let me just run it. Okay, so here you can see we have successfully created our first table. Now you can use the describe command to see the structure of the table. I'll write describe emp underscore details. If I run this, there you go. So under field you can see the column names, then you have the data types. Null represents if the table can accept null values or not, and these are basically empty, and we haven't set any default constraint. Alright, moving ahead, now let's learn to add data to our table using the insert command. So on a notepad I have already written my insert statement, so let me just copy it and then I'll explain it one by one. Alright, so if you see this, so we have used an insert into statement or a command followed by the table name, that is emp details. Then this is the syntax. Using values, I have passed in all the records. So first we have Jimmy, which is the name of the employee. Then we have 35, which basically represents the age. Then M means the gender or the sex. Then we have the date of join. Next we have the city to which the employee belongs to, and finally we have the salary of the employee. So this particular information represents one record or a tuple. Similarly, the next employee we have is Shane. You can see the age and other information. Then we have Mary, this Dwayne, Sarah, and Amy. Alright, so let me go ahead and run this. So this will help you insert the values in the table that you have created. You can see we have successfully inserted 6 records. Now to display the records, let me use the select statement. So I'm using select star from emp underscore details. If I run this, you can see my table here and the values it has. So we have the name column, the age column, the state of join, city, salary, and these are the values that you can see here. Moving ahead, now let's say you want to see the unique city names present in the table. So in this case, you can use the distinct keyword along with the column name in the select statement. So let me show you how you can print the distinct city names that are present in our table. Now if you notice this table clearly, we have Chicago, Seattle, Boston, Austin, there's New York, and there's Seattle repeated again. So I only want to print the unique values. So for that, I can write my select statement as select distinct. Then I'll give my column name, which is city, from my table name, that is emp details. If I run this, you can see my query has returned 5 rows and these are the values. So we have Chicago, Seattle, which was repeated twice, is just been shown once. Then we have Boston, Austin, and New York. Now let's see how you can use inbuilt aggregate functions in SQL. So suppose you want to count the number of employees in the table. In that case, you can use the count function in the select statement. So let me show you how to do that. So I'll write select. I'll use my function name, that is count. Now since I want to know the total number of employees, I'm going to use their name inside the brackets from employee underscore details. Now if I run this, this will return the total number of employees that are present in the table. So we have 6 employees in total. Now if you see here in the result it says count name. Now this column is actually not readable at all. So what SQL provides is something called as an alias name. So you can give an alias to the resultant output. So here I can write select count of name and use an alias as I can give an alias as count underscore name and run this statement again. There you go. You can see here in the resultant output we have the column name as count name, which was our alias name. Now suppose you want to get the total sum of salaries, you can use another aggregate function called sum. So I'll write my select statement, and this time instead of count I'm going to write sum, and since I want to find the sum of salaries, so inside the bracket I'll give my salary column from my table name, that is employee details. If I run this will result in the total sum of salaries. So basically it adds up all the salaries that were present in the salary column. Now let's say you want to find the average salary. So instead of sum you can write the average function, which is avg. So this will give you the average salary from the column salary. So you can see it here, this says average salary. Now if you want you can give an alias name to this as well. Now you can select specific columns from the table by using the column names in the select statement. So initially we were selecting all the columns. For example, like you saw here, the star represents that we want to see all the columns from the employee details table. Now suppose you want to see only specific columns, you can mention those column names in the select statement. So let's say I want to select just the name, age and the city column from my table, that is employee details. So this will result in displaying only the name, age and city column from the table. If I run it, there you go. It has given only 3 columns to me. Now SQL has a where clause to filter rows based on a particular condition. So if you want to filter your table based on specific conditions, you can use where clause. Now where clause comes after you give your table name. So suppose you want to find the employees with age greater than 30. In this case you can use a where clause. So let me show you how to do it. I'll write select star from my table name, that is employee details, and after this I'll use my where clause. So I'll write where age greater than 30. If I run this, it will give me the output where the age is only greater than 30. So it excluded everything that is less than 30. So we have 4 employees whose age is greater than 30 here. Now suppose you want to find only female employees from the table, you can also use a where clause here. So I'll write select, let's say I want only the name, the gender, which is sex here, comma city from my table, that is employee details, where I'll give my column name, that is sex, is equal to, since I want only the female employees, I'll give F and run this statement. Okay, you can see here our employee table has 3 female employees. Now suppose you want to find the details of the employees who belong to Chicago or Austin. In this case you can use the OR operator. Now the OR operator in SQL displays a record if any of the condition separated by OR is true. So let me show you what I mean. So since I want the employees who are from Chicago and Austin, I can use an OR operator. So I'll write select star from emp details, which is my table name. Then I'll give my where clause, where city equal to, I'll give my city name as Chicago, and then I'm going to use the OR operator, or city equal to, I'll write Austin. I'll give a semicolon and let me run it. There you go. So in the output you can see all the employees who belong to the city Chicago and Austin. Now there is another way to write the same SQL query. So you can use an in operator to specify multiple conditions. So let me just copy this, and instead of using the or operator, this time I'm going to use the in operator. So I'll delete this. After the where clause, I'm going to write where city and use the in operator. Inside bracket, I'll give my city names as Chicago and I want Austin. So I'll give a comma and write my next city name, that is Austin. So this query is exactly the same that we wrote on top. Let me run this. You will get the same output. There you go. So we have Jimmy and Dwayne, who are from Chicago and Austin respectively. Now SQL provides the between operator that selects values within a given range. The values can be numbers, text or dates. Now suppose you want to find the employees whose date of join was between 1st of Jan 2000 and 31st of December 2010. So let me show you how to do it. I'll write select star from emp details where my date of join, that is DOJ, between, I'll give my two date values, that is 1st of Jan 2000 and I'll give my second value, the date value, that is 31st of December 2010. So every employee who has joined between these two dates will be displayed in the output. If I run it, we have two employees who had joined between 2000 and 2010. So we have Jimmy and Mary here, who had joined in 2005 and 2009 respectively. Alright. Now in where clause, you can use the AND operator to specify multiple conditions. Now the AND operator displays a record if all the conditions separated by AND are true. So let me show you an example. I'll write select star from employee details table where I want the age to be greater than 30 and I want sex to be male. Alright, so here you can see I have specified two conditions. So if both the conditions are true, only then it will result in an output. If I run it, you can see there are two employees who are male and their age is greater than 30. Now let's talk about the group by statement in SQL. So the group by statement groups rows that have the same values into summary rows. Like for example, you want to find the average salary of customers in each department. Now the group by statement is often used with aggregate functions such as count, sum and average to group the result set into one or more columns. Let's say we want to find the total salary of employees based on the gender. So in this case you can use the group by clause. So I'll write select, let's say sex, comma, I want to find the total sum of salary as I'll give an alias name, let's say total salary, from my table name, that is employee details. Next I'm going to group it by sex. Okay, let me run it. There you go. So we have two genders, male and female, and here you can see the total salary. So what this SQL statement did was, first it grouped all the employees based on the gender and then it found the total salary. Now SQL provides the order by keyword to sort the result set in ascending or descending order. Now the order by keyword sorts the records in ascending order by default. To sort the records in descending order, you can use the DESC keyword. So let's say I want to sort my employee details table in terms of salary. So I'll write select star from emp underscore details and I'll use my order by clause on the salary column. So this will sort all the records in ascending order of their salary, which is by default. You can see the salary column is sorted in ascending order. Now suppose you want to sort the salary column and display it in descending order, you can use this keyword, that is DESC. Let me run it. You can see the output. Now this time the salary is sorted in descending order and you have the other values as well. Now let me show you some basic operations that you can do using the select statement. So suppose I write select and do an addition operation, let's say 10 plus 20, and I'll give an alias name as addition. If I run this, it will give me the sum of 10 and 20, that is 30. Similarly, you can use the subtraction operator and you can change the alias name as, let's say, subtract. Let's run it. You get minus 10. Now there are some basic inbuilt functions. There are a lot of inbuilt functions in SQL, but here I'll show you a few. Suppose you want to find the length of a text or a string, you can use the length function. So I'll write select and then use the length function. I'll hit tab to autocomplete. Let's say I want to find the length of country India and I'll give an alias as total length. If I run it, you see here it returns 5 because there are 5 letters in India. There's another function called repeat. So let me show you how repeat works. So I'll write select repeat. Let's say I want to repeat the symbol that is at the rate. I'll put it in single quotes because it is a text character, and I want to repeat this character for 10 times. Close the bracket and let's run it. You can see here in the output it has printed at the rate 10 times. You can count it. Alright. Now let's say you want to convert a text or a string to uppercase or lowercase. You can do that as well. So I'll write select and use the function called upper. Let's say I want to convert my string, that is India, to uppercase. I'm not giving in any alias name. If I run this, see, my input was capital I and everything else was in small letter. In the output you can see it is converted my input to all caps. Similarly, you can change this. Let's say you want to print something in lowercase, you can use the lower function. Let's say this time everything is in uppercase. If I run it, it converts India to lowercase. Now let's explore a few date and time functions. Let's say you want to find the current date. There's a function called CUR, which stands for current, and this is the function I'm talking about, which is current date. If I run this, you will get the current date, that is 28th of Jan 2021. And let's say you want to extract the day from a date value, so you can use the day function. Let's say I'll use day and I want to find the day from my current date. If I run this, you get 28, which is today's day. Now similarly, you can also display the current date and time. So for that you can use a function that is called now. So this will return the current date and time. You can see this is the date value and then we have the current time. Alright, and this brings us to the end of our demo session. So let me just scroll through whatever we have learned. So first I showed you how you can see that databases present in MySQL. Then we used one of the databases and checked the tables in it. Then we created another database called SQL Intro for our demo purpose. We used that database and then we created this table called employee details with column names like name, integer, the sex, date of join, city and salary. I showed you the structure of the database. Let me run this again so you get an idea. You can see this was the structure of our table. Then we went ahead and inserted a few records. So we inserted records for 6 employees. So you have the employee name, the age, the gender, the date of join, the city to which the employee belongs to, and the salary of the employee. Then we saw how you can use the select statement and display all the columns present in the table. We learned how you can display the unique city names. We learned how to use different aggregate functions like count, average, and sum. Then we learned how you could display specific columns from the table. We learned how to use where clause. Then we used an or operator. We learned about in operator, the between operator. Then we used an and operator to select multiple conditions. Finally, we learned about group by, order by, and some basic SQL operations. Now it's time to explore some string functions in MySQL. So I've given a comment, string functions. First, let's say you want to convert a certain string into uppercase. So I can write select. The function I'll use is upper, and within this function you can pass in the string. Let's say I'll write India. If you want, you can give an alias name as, let's say, uppercase. I'll give a semicolon and let's run it. There you go. So my input was in sentence case, and using the upper function we have converted everything into uppercase. Similarly, let me just copy this and I'll show you. If you want to convert a string into a lowercase, you can use the lower function. I'll run this. You can see the result. Everything is in lowercase now. Of course, I need to change the alias name to lowercase. Now, instead of using lower as the function, there is another function that MySQL provides, which is called the L case. So I'll just edit this and write L case, and let's say I'll write India in uppercase. Let's run it. It returns me the same result. Cool. Now moving on, let's say you want to find the length of a string. You can use the character length function. I'll write select, use the function character length, and I'm again going to pass in my string as India as, let's say, total length. Let's run it. This time I'm going to hit Control Enter to run my SQL command. There you go. It has given us the right result, which is 5, because India has 5 characters in it. Now these functions you can also apply on a table. Now let me show you how to do it. Let's say we already have the students table and you want to find the length of each of the student names. So here you can pass stu_name and you can give the same alias name, let's say total length, and then you can write from table name, that is students. If I run this, you can see the output. It has given me total 20 rows of information. This is not readable actually. Let me also display the student names so that we can compare their length. Alright, I'll run this again and now you can see the result. So Joseph has 6 characters, Nilesh has 6, Vipul has 5, Anubhav has 7. Similarly, if you see, Akshay has 6, Tanishq has 7, Raghav has 6, Cummins has 7, Rabada has 6, so on and so forth. Now instead of using this character length, you can also use the function char length. It will work the same way. Let's see the result. There you go. It has given us the same result. You can either use character length or char length. Now there's another very interesting function called concat. So the concat function adds 2 or more expressions together. Let's say I'll write select. I'll use the function concatenate. The function is actually concat, and I'm going to pass in my string values. Let's say India is in Asia. Let's run this and see our result. You can see here it has concatenated everything. Let us make it more readable. I'll give a space in between so that you can read it clearly. Now this is much more readable. India is in Asia, and if you want you can give an alias name as well, as let's say merged. There you go. Now the same concat operation you can also perform on a table. I'm going to use the same students table. Let's say I want to return the student ID followed by the student name, and then I am going to merge the student name followed by a space followed by the age of the student, and I can give an alias as let's say name underscore age from my table, that is students. Let's see how this works. Okay, you see here the result is very clear. We have the student ID, the student name, and the concatenated column that we created, which was name underscore age, where we have the student name with a space followed by the age of the student. If I scroll down, you can see the rest of the results. Cool. Now moving ahead, let's see how the reverse function works in MySQL. So the MySQL reverse function returns a string with the characters printed in reverse order. So suppose I write select reverse. I'll use the same string again. Let's say I have India. Let's run it. You will see all the characters printed in reverse order. Again, you can perform the same operation on a table as well. Let's say I'll write select reverse, and I'll pass in the column as student name from my table, that is students. Let's run it. It gives you 20 students and all the names have been printed in reverse order. Okay. Now let's see what the replace function does. So the replace function replaces all occurrences of a substring within a string within a new substring. So let me show you what I mean. I'll write select replace. I'll pass in my input string, which is let's say orange is a vegetable, which is ideally incorrect. I'm purposely writing this so that I can replace the word vegetable with fruit. Okay, so what this replace function does is it is going to find where my word vegetable is within the string, my input string, and it is going to replace my word vegetable with fruit. Let's run it and see the output. There you go. Now this is correct, which is orange is a fruit. Alright. Now MySQL also provides some trim functions. You can use the left trim, right trim, and just the trim function. So let me show you how this left trim works. Left trim or L trim removes the leading space characters from a string passed as an argument. So say I write select, I'll use the left trim function, which is L trim, and then I'm going to purposely give a few spaces in the beginning of the string. I'll give a word, let's say India, and then I'll give some space after the word India, and see how the L trim works. If I run this, it gives me India, which is fair enough. But before that, let's first find the length of my string. So I'll use my length function here, and within this function I am going to find the length of my string, which has India along with some leading and trailing spaces. I'll paste this here, give a semicolon, and I'll run it. Okay, so the entire string is 17 characters long, or the length of the string is 17. Now say I use ltrim on my same string, what it returns me is India, and if I run length over it, you can see the difference, as in you can see how many spaces were deleted from the left of the string. You can see here, now it says 17, and I'm going to use ltrim. Let's see the difference. It gives me 12. The reason being, it has deleted 5 spaces from the left. You can count it, 1, 2, 3, 4 and 5. So 17 minus 5 is 12, which is correct. Similarly, you can use the rtrim function, which removes the trailing spaces from a string. Trailing spaces are these spaces. When you use left trim, it deletes the leading spaces, which is this. Now let me just replace ltrim with rtrim, which stands for right trim, and see the result. So the length is 10 now. The reason being, it has deleted 7 spaces from the right of the string. If you can count it, 1, 2, 3, 4, 5, 6 and 7. Cool. You can also use the trim function, which will delete both the leading and the trailing spaces. So here, if I just write trim and I'll run it, it gives me 5, because India is total 5 characters long and it has deleted all the leading and the trailing spaces. Alright. There's also a function called position in MySQL. The position function returns the position of the first occurrence of a substring in a string. So if the substring is not found with the original string, the function will return 0. So let's say I'll write select position. I want to find where fruit is in my string, that is orange is a fruit. I'll give an alias as name. There's some error here. This should be within double quotes. Now let's run it and see the result. Okay, it says at the 13th place, or at the 13th position, we have the word fruit in our string, which is orange is a fruit. Now the final function we are going to see is called ASCII. So the ASCII function returns the ASCII value for a specific character. Let's say I write select ASCII of the letter small a. If I run this, it will give me the ASCII value, which is 97. Let's say you want to find the ASCII value of 4. Let's see the result. It gives me 52. Alright. In this session, we are going to learn 2 important SQL statements or clauses that are widely used, that is group by and having. First, we'll understand the basics of group by and having, and then jump into MySQL Workbench to implement these statements. So let's begin. First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no 2 rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement, and then followed by the column names that we want to select. From, we have the table name, followed by the where condition, and next we have the group by clause, and here we include the column names. Finally, we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company, Then we have the department to which each of these employees belong to. We have the city to which the employees belong to. And then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department, and then we are using an aggregate function, that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name which is average underscore salary, which appears in the output, you can see here, from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL workbench, where we will implement group by and solve specific problems. Okay, so I am on my MySQL workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query, that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright. Now you can check the tables that are present in SQL underscore intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer, and I'll assign employee ID as my primary key. Next, I'll give employee underscore name, and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next, we have the date of join, and the data type will be date. We have the department column as well. This is going to be of varchar, and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees, and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad, and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information, and now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami, and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned, and here are the department names. So we have sales, marketing, product, tech, IT, finance, and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select AVG, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, so the average age of all the employees in our table is 33.35. Now say you want to find the average age of employees in each department. So for this you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left, and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says AVG of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places. So I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright, now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma, now I want the total salary, so I'll use the sum function, and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again, and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity. Quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next, we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 1, 2, 3, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 1 to 1 and let's say 1 to 3, since we have just two product IDs here. So for that you can use the select query. So I'll write select product ID. Next, I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally, I'll group it by product ID. Let's run it. There you go. So here you can see we have the two product IDs 1 to 1 and 1 to 3, and here you can see the revenue that was generated from these two products. Alright. Now let's say we have to find the total profit that was made from both the products 1 to 1 and 1 to 3. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 1 to 1. Let's say the cost price was $270 for each, and next we have my product as 1 to 3, and let's say the cost price for product 1 to 3 was $250. Let's insert these two values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table, as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID Next, I'm calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I'm using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by c.product ID. Let's run this. There you go. So here you can see for product ID 121 we made a profit of $1,100, and for product ID 123 we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL Workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function that is average salary. I'll give an alias name as avg underscore salary from employees. Next we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause I'll use my condition that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function, and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma. This time, since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next, I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city, having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees, group by department, and in the having clause I'm going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay, so let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. In this session we will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on MySQL Workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command, and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL Workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL Workbench 8.0 version installed. I'll click on it. So it will take some time to open. Okay, I'll click on this local instance and here I'll give my password. Okay, so this is how an SQL editor on MySQL Workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Control Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL Joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay, now to understand inner join, consider that there is a college, and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket underscore ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay. Now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Astle. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c.name is equal to f.name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore ID, comma, f dot name, from, I'll write cricket as C, inner join football as F, on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay. Now let me just show the different tables that are part of classic tables. Alright. So here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products, and product lines as well. Alright, so let me use my select statement to show what are the columns present in the products table. Okay, so this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product, then we have the quantity in stock, buying price, and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright, now suppose you want to find the product code, the product name, and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description, so I'll write this column name. Okay, then I'll use from my first table, that is products, inner join product lines, I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes, then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join three tables, that is orders, order details, and products. So first let me show you what are the columns we have in these three tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product, we have the price of each product, then we have the order line number. Okay, so using the product, orders, and order details, let's perform an inner join. So I'll write select O dot order number, comma, O dot status, comma, I need the product name which I'll take from the products table, so I'll write P dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma, since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD. On, I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to OD dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name, and the revenue. This we got it using inner join from 3 different tables. Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement, and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write A dot key is equal to B dot key. Okay, now in our classic models database we have 2 tables, customers and orders. So if you want to find the customer name and their order ID, you can use these 2 tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are 2 address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing, there are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name there were no orders. And similarly, if I scroll down, you will find a few more null values. You can see here there are two null values here. For customer number 168 and 169, there were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is, here I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, right join table B on the common key column from both the tables. Alright. Now to show how right join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name, then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name, we have the extension, the email ID, the job title, and also reports to here means the manager. Okay, so based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on E dot, my common key column is employee number here, so I'll write E dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL, known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, and here if you see we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056, the manager is 1002. So if you check for 1002, we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102, the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188, we have the manager as 1143. Now if I check the table at 1143, we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright, now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma. Next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma, and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot. I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column. and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma O dot order number. So I just want to know the customer name and the order number related to the customer. From, I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join, I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright. So that brings us to the end of our demo session. So let me just run through whatever we did in this session. So first we created a database called SQL Joins. Then we created two tables like cricket and football. Then we had inserted a few rows to each of these tables. Then we used this table to learn about inner join. Next, we used a database called classic models. It had multiple tables, so we explored all of these tables like products, there was product lines, orders, customers and employees, and learned how to use inner join, left join, self join, right join, as well as full outer join. In this video we will learn what is a subquery and look at the different types of subqueries. Then we'll learn subqueries with select statement followed by subqueries with insert statement. Moving further, we will learn subqueries with the update statement, and finally we look at subqueries with delete statement. All this we will be doing on our MySQL Workbench. So before I begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. So let's start with what is a subquery. So a subquery is a select query that is enclosed inside another query. So if I show you, this is how the basic structure of a subquery looks like. So here, whatever is present inside the brackets is called as the inner query, and whatever is present outside is called the outer query. So first, the inner query gets executed and the result is returned to the outer query, and then the outer query operation is performed. Alright, now let's see an example. So we have a question at hand, which is to write a SQL query to display department with maximum salary from employees table. So this is how our employees table looks like. It has the employee ID, the employee name, age, gender, we have the date of join, department, city and salary. Now to solve this query, my subquery would look like this. So I'll first select the department from my table, that is employees, where I'll use the condition salary equal to, and then I'll pass in my inner query, which is select max of salary from employees. So what this does is it will first return the maximum salary of the employees in the table. Then our outer query will get executed based on the salary returned from the inner query. So here the output is department sales has the maximum salary. So one of the employees from the sales department earns the highest or the maximum salary. If you see in our table, the employee is Joseph, who earns $115,000. Alright, and Joseph is from the sales department. Now let's see how this query works. So here we have another question, which is to find the name of the employee with maximum salary in the employees table. So this is our previous employees table that we saw, and to find the employee who has the maximum salary, my subquery would look something like this. So I'm selecting the employee name from my table, that is employees, where I'm using the condition salary equal to, and then I'm passing in my subquery or the inner query. So first I'm selecting the maximum salary. This will return a particular value, that is the highest salary from the table. And if you see our table, the highest salary is $115,000. So our query becomes select employee name from employees where salary equal to $115,000. So the employee name is Joseph here, and that's the output. Now if you want to break it down, here you can see first the inner query gets executed. So our SQL query will first execute the inner query that is present inside brackets, select maximum salary from employees. The result is $115,000, and then based on the returned result, our outer query gets executed. So the query becomes select employee name from employees where salary equal to $115,000, and that employee is Joseph.
Imagine you're working at Facebook, where millions of people are constantly posting updates, liking photos, and commenting on your post. And to keep running everything smoothly, Facebook uses SQL. When you post a status update, SQL saves it to the database. When your friends like or comment on your post, SQL quickly finds and shows you this information. SQL links all these actions together, making sure everything works seamlessly. By learning SQL, you can manage and organize large amount of data efficiently, just like Facebook does to keep its users connected and engaged. That is why SQL is one of the best language for database management, which stands for Structured Query Language. SQL is a programming language made for managing and working with relational databases. It lets users to easily retrieve, insert, update, and delete from databases. So this video will guide beginners through the key steps and concepts needed to become skilled in SQL. To become a SQL developer, you should follow a structured plan. So here is a step-by-step guide to help you to learn SQL and start your career in this field. So without any further ado, let's get started. So the number one is start understanding RDBMS. The first step in learning SQL is to get to know the most popular relational database management system, RDBMS. These systems are the base for using SQL. The four most common RDBMS are Oracle, MySQL, Microsoft SQL Server, PostgreSQL. So the first one is Oracle. Oracle database created by Oracle Corporation is a top RDBMS known for being scalable, reliable, secure, and high performing. The second one is MySQL. MySQL is a popular free and open source RDBMS known for its ease to use, reliability, security, and scalability. The third one is Microsoft SQL Server. Developed by Microsoft Corporation, SQL Server is a flexible RDBMS trusted for secure and efficient data storage. The last one is PostgreSQL. PostgreSQL is a free and open source RDBMS known for its advanced feature and robustness. The next step is pick an ID. After you understand RDBMS, the next step is to choose and install Integrated Development Environment IDE. So some popular IDEs for SQL development are pgadmin, an open source platform for managing and querying PostgreSQL databases. It has many tools for database management. The second one is MySQL Workbench, a visual tool for designing, developing, and managing MySQL databases. It integrates SQL development and administration. The third one is Azure Data Studio, a modern open source and cross-platform tool by Microsoft that supports multiple database systems like SQL Server, PostgreSQL, and MySQL. The fourth one is Oracle SQL Developer, a free IDE from Oracle that helps in developing and managing Oracle databases. The third step is learning the basic SQL commands. The main goal of learning SQL is to master the basic command. So these commands are grouped into four main categories. First one is data manipulation language, the second one is data definition language, DDL, the third one is DCL, and the fourth one is TCL. So data manipulation language, DML, these commands are used to work with the data in the databases. The main DML commands are insert, update, delete, and many more. The second one is data definition language, DDL. These commands are used to set up and change the structure of database, like creating, altering, or deleting tables, indexes, and views. The main DDL commands are create, alter, drop, and truncate. The third one is DCL, data control language. These commands are manage user permissions and access to the database. The main DCL commands are grant and revoke. The fourth one is TCL, transaction control language. These commands control transaction in the databases. The main TCL commands are commit, rollback, and save point. The fourth step is understand SQL keywords. SQL keywords are important for performing tasks in a database like retrieving and managing data. Some commonly used SQL keywords include, the first one is select, used to retrieve data from a database. The second one is from, specifies the table from which to retrieve or delete data. The third one is where, filter results to include only records that meet certain criteria. The fourth one is order by, sorts the retrieved data in ascending or descending order. The next is insert into, adds new rows to a table. The next is update, modifies existing data in a table. The next is delete, removes data from a table. The another one is create table, creates a new table in the databases. The another one is drop table, deletes an existing table in the databases. The last one is alter table, modifies, adds, or deletes columns in an existing table. And the fifth step is master SQL data types. So understanding SQL data types is crucial for storing and handling data in a database. The most common SQL data types are, the first one is string data types, used for text, names, and addresses. The second one is numeric data types, used for numbers like integers and decimals. The third one is date and time data types, used for storing dates and times. So these three are the common data types in SQL. So the next step is know the types of SQL operators. SQL operators are symbols used for perform different operations on database. The main types of SQL operations are, the first one is arithmetic operators, used for addition, subtraction, multiplication, division, exponential, and modulus operation. The second one is logical operators, used to combine two or more relational statements like all, and, any, some, like. The third one is comparison operator, used to compare the contents of a field with another field or a constant. So after learning SQL operators, let's jump into the 7th point, learn about SQL data constants. So constants are the rules that limit the type of data allowed in a table, ensuring accuracy and reliability. If a constant is violated, the action will be stopped. The most common SQL data constants are, the first one is not null, ensures a column cannot have a null value. The second one is unique, ensures all the values in a column or a group of columns are unique. The third one is primary key, uniquely identifies each row in a table, combines not, null, and unique. And the next one is check, ensure all the values in a column meet a specific condition. And the next step is learn about SQL normalization forms. Normalization is organizing data in a database to reduce redundancy and improve integrity. So there are several levels of normalization, each with specific rules. So the first one is 1NF, first normal form, and the second one is second normal form, 2NF. The third one is third normal form, 3NF. And the fourth one is boys code normal form, BCNF. And the next step is explore advanced SQL concept. As you advance in SQL, explore more complex topics to enhance your skills. So the first one is joins. Learn to merge data from different tables based on common conditions using various types of joins like inner join, left join, right join, or full join. The second thing is indexes. Improve query performance by creating and managing indexes, which speed up data retrieval, especially for large data sets. The third is subqueries. Use queries within other queries to retrieve data from the multiple tables at once, allowing for more complex data operation. The fourth one is recursive queries. Write queries that call themselves until a condition is met, useful for working with hierarchical or self-referencing data. The last one is pivot and unpivot. Use pivot to aggregate multiple rows into one and unpivot to transform column into rows, helping to reformat and analyze data. So becoming good at SQL takes time, effort, and a love for learning new things. By following this step-by-step plan, you can learn SQL well. You will build solid understanding and gain the skills to handle data in databases efficiently.
In this video, we will discuss an advanced SQL concept called triggers. We will learn what triggers are and how they can be used to solve problems. We'll look at how trigger queries are written on MySQL Workbench. So let's get started. First, what are triggers in SQL? So a trigger is a user-defined SQL command that is invoked automatically when an event occurs. An event can be related to inserting, updating, or deleting records in a table. In MySQL, triggers can be executed automatically by the Oracle server. Below is how the syntax of writing a trigger is. So you write create trigger followed by the trigger name. Now the trigger name should be a valid SQL name. Then we have the trigger time, the trigger event, and then on the name of the table. Then we write for each row begin followed by the list of SQL statements, and finally we write end. Now in the syntax, the trigger time represents either before or after an event, and a trigger event can be an insert, update, or delete operation. Now let me take you to MySQL Workbench, where we will learn how to create triggers and explore more on how it works. So I am on MySQL Workbench. So first let me go ahead and create my connection. I'll give my password. Alright, now this will take you to my SQL editor. Okay, so first and foremost, let me create a new database called triggers. So I'll write my SQL command as create database triggers. Let me run this. Okay, so you can see here one row affected. I have created my database, that is triggers. Next, I'm going to move inside this database, so I'll write the command use triggers. Let's run this. Okay, now inside this triggers database, we'll be creating our different tables. So let's check if we have any tables. I'll use the command show tables. Now you see there are no tables in this database. Alright. First, let's see how before insert trigger works. So for before insert trigger, we'll create a table called customers and verify the age of each customer. So I'll give a comment before insert trigger. So let me go ahead and create my customers table. I'll write create table customers, and I'll give my column names as cust_id, which is customer ID. This is going to be an integer. Then we have the age of the customer. This is again an integer, and we'll have the name of the customer. The name of the customer will be of varchar type. I'll give the size as 30. Alright. Let's create this table. Okay, so we have successfully created our customers table. Now moving ahead, I'm going to write my before insert trigger command. So we'll start with a delimiter. So a delimiter is a marker for the end of each command. Next, I'll write my create trigger followed by the trigger name. I'll give a valid trigger name such as age_verify. I'll write before trigger. It should be before insert on. My table name would be customers. Then I'll write for each row if new dot age is less than 0, then set new dot age equal to 0, which means while inserting your values to the age column, in case the age value is negative, we'll convert the age to 0. I'll give a semicolon and then I'll write end if. I'll give another semicolon and I'll close the delimiter. Now let me run this. Okay, so we have created our trigger. Now let's insert a few values onto customers. So I'll write insert into customers values 101, which is the customer ID. I'll give the age as 27 and let's say the name of the customer is James. Let's insert another record. Give the value as 102 and this time I'm purposely giving the age as -40, which is less than 0, so that you can see the output clearly. I've given the customer name as Amy. Let's insert 2 more records. The customer ID with 103 has an age of 32 and let's say the name is Ben. I'll give another comma and finally we'll insert our 4th customer record. The customer ID is 104. The age I'm giving as -39, which is less than 0 again, and let's say the customer name is Angela. Alright, now let me run this. Okay, so we have successfully inserted 4 rows of information to our customers table. Now let's see the difference. Since we had created a age verify trigger which would change the values of the age column in case the age value is less than 0. So now that we have inserted 4 records to a customer, so let's see what we have in the customers table. Now let me run it. There you go. So if you see this, for those customers where the age was less than 0, such as 102 and 103, you can see here our trigger has automatically converted those values to 0. If you can see the trigger we had created, we had set our new age to 0 if the age was less than 0. And this is the output we get. So here we looked at how a before insert trigger works. Alright, now moving ahead, let's understand how an after insert trigger works. So I'll give a comment here as after insert trigger. Now in this example, we'll create 2 tables, customers and message. Now the trigger will be fired if the birthday column has a null value in the customers table. You will get a message to update your date of birth. Okay, so first let me create my customers table. Now since we already have one customers table, I'll name it as customers 1 and let me give the column names. So the first column would be the ID column. This is going to be an integer, and I'll use the auto increment parameter, and this will be my primary key as well. Next, we'll have the name of the customer. This is going to be of type varchar, and I'll use not null constraint. Next, we'll have the email ID of the customer. This is again going to be of varchar type, and the column we are interested in is the birthday column. So I'll write birth date. This is going to be of type date. Okay, so let's create our table. Alright, now we'll create our second table, which is going to be message. Let's create the columns. This will have ID, int, and I'll use the auto increment operator. Next, we'll have the message ID. This is going to be of integer type. We'll have a column called message. This will be of varchar type, let's say 300 characters, and not null. And I'm going to set my primary keys as ID and message ID. Let's create our second table then. So we have some error here. Let's debug the error. Okay, so I forgot to close the bracket here. Alright, now let me run this table. Alright, so we have created our message table as well. Next, I'll write my after insert trigger command. So I'll write delimiter. Next, I'll use create trigger command. So I'll write create trigger. My trigger name would be check underscore null underscore date of birth. After insert on customers 1 for each row begin if new dot birth date is null, then we are going to insert into our message table. We'll give the columns as message ID and message values new.id, comma, I'm going to use the concat function where I'll give my message, let's say hi, followed by the name, followed by, let's say, please update your date of birth. Okay, now I'll write end if. I'll close the delimiter. Okay, so let me go to the top and recheck if you have created a trigger correctly. So I have my trigger name after insert on customers 1 for each row begin if our new birthday has a null value, then we'll pass in a message saying hi, the name of the customer, then the message would be please update your date of birth. Alright, so let's run the trigger. Okay, now the next step is to insert a few records to customer table. So my name of the table is customers1. Okay, I'll give the column names as name, email and birth. Okay, we'll pass in a few values. So our first customer's name, let's say, is Nancy, comma, I'll give my email ID, let's say nancy@abc.com. Now let's say I'm purposely passing the date of birth as null. I'll give a comma. My next customer, let's say the name of the customer is Ronald, and then I'll give the email ID such as ronald@xyz.com, and this time I'm going to pass in the date of birth, let's say 1998 November, and let's say 16th. Okay, now we'll add another customer, let's say Krish. We'll give the email ID of Krish, so krish@xyz.com, and let's say we'll give the date of birth as 1997 08/20, and finally we'll add one more record for another customer, let's say Alice. I'll give the email ID as alice@abc.com, and this time I'll purposely pass the date of birth as null. Alright, so let's run the insert query. Okay, now let me display the message table for you so that you can see the output and how our after insert trigger works. There you go. So if you see this, we had inserted 4 rows of information, out of which the first customer ID and the fourth ID had null date of birth. So for those two values you have the message as hi Nancy, please update your date of birth, and then you have hi Alice, please update your date of birth. Now you can give a space between hi and the name of the customer. Alright, now moving ahead, let's understand how before update trigger works. So I'll give a comment here as before update. Okay, now to show you how before update works, first we'll create a table called employees. Alright, so let me create my table, that is create table employees. I'll give my column as employee ID. This is going to be an integer type and it will be my primary key. Next we'll have the employee name. This will be of varchar type, and let's say the size would be 25, comma, then we'll have the age of the employee. Age will be of integer type, and finally we'll have the salary of the employee. Salary will be of type float. Let's create this table. Alright, now the next step is to insert a few records to our employees table. Okay, so here on the notepad I have already written my insert query. So I have inserted nearly 7 records. So let me paste it here. Alright, I'll just go ahead and run this insert query so that we'll insert 7 employees to our table. Okay, next we'll write our before update trigger command. So first and foremost I'll write my delimiter. followed by the create trigger command. I'll give my trigger name as update underscore trigger. Let's bring this to the top. Okay. I'll use before update on my table, that is employees. For each row, I'll write begin. My condition would be if new dot salary is equal to, let's say, $10,000. I'll write then set new dot salary equal to $85,000. I'll give a semicolon. Then I'll use else if new dot salary is less than $10,000, then I'll set new dot salary to, let's say, $72,000. I'll give a semicolon. I'll end the if statement. I'll close the delimiter by giving a semicolon. Okay. So if you see the employees table, we have the salary values here. Now in case while updating the table, if the salary is equal to $10,000, we'll set the new salary to $85,000. Else, if the salary is less than $10,000, we'll set the salary column values to $72,000. So let's go ahead and run this trigger query. Alright. Now let me use my update command. So I'll write update employees. I'll write set salary is equal to, let's say, $8,000. Now if you see our trigger query, we are setting the salary to $8,000, which is clearly less than $10,000. So our new salary would be $72,000. So let me run this. Okay. So you can see here 6 rows affected. So I'll write now select star from employees. Let's run this. Okay. If you see this, we have converted our salary column to $72,000 since we updated the salary to $8,000, and according to our trigger query, if it's less than $10,000, the salary should be $72,000, which you can see here. Alright, now moving to our final demo. This time we are going to explore how before delete trigger command works. So in this example, we'll create a table called salary. We'll store the deleted record in a new table using the before delete trigger. So first, I'll give my comment as before trigger. Comments are always useful since they make your query more readable. So let me now create my salary table. So I'll write create table salary. I'll give my column names as EID, which is employee ID, and I'll set it as primary key, comma. I'll give another column, let's say valid from, which means the date from which this salary was effective. This is going to be of type date and not null. And then I'll have the amount. Amount will be of type float, and again not null constraint. Let me run the create table command. Okay, so we have created our salary table now. The next thing is to insert a few values. So I'll write insert into salary. I'll give my column names as EID, comma, valid from, comma, amount. I'll write values. My first employee ID would be 101, followed by a date, let's say 2005, May, and 01, which is 1st of May 2005. Let's say the amount is $55,000. I'll give another row of information. This time the employee ID is 102, and I'll give a valid from date. Let's say the amount is 68,000. I'll give another employee ID, let's say 103, 2006, 0901, and let's say the amount is $75,000. Okay, let's run this. Alright, you can verify also, so I'll write select star from salary. You can see here we have inserted 3 rows of information. Alright, the next step is to create another table that will store the deleted rows. So I'll write create table. Let's say the name of the table is create, or let's say salary delete. I'll write salary del. Now this will have the ID, the type would be integer, and primary key. I'll also use the auto increment operator. Next we have the EID, which is of type integer. I'll write valid from date and not null. Then I have the amount column, which is of type float and not null. My final column would be deleted at. The data type will be timestamp. I'll use the default constraint as now. So this will return the time and the date at which the record was deleted. Alright. Let me create this table. Okay. Finally, let me write my before delete trigger command. So I'll first declare my delimiter. Let's say this time I'm using the dollar symbol. I'll write create trigger. My trigger name would be salary underscore delete before delete on my table, that is salary. For each row I'll write begin. Next, let's insert into salary delete. I'll give my columns as employee ID, valid from, and amount. Now we'll insert a few values. I'll write values old dot eid, comma old dot valid from, comma old dot amount. I'm going to close with the delimiters. Alright, so let's run our before delete trigger. Alright, now let me go ahead and delete one of the records from the salary table. So I'll write delete from salary where employee ID is, let's say, 103. Let me run this query. Okay, so you have successfully deleted one of the records in the table. Now if you see our other table, that is salary delete, you will find this information present in the salary delete column. So we had deleted one row of information, that is for employee ID 103, which you can find it here. Now the final column, that is delete at, shows the time at which the information was deleted or the row was deleted. Alright, so let me go to the top and just give you a recap of what we did in this demo. So first we created a database called triggers. Then we started with before insert trigger, where we inserted customer table, and then we verified the age of the customers. So we saw if the age was less than 0, then we set the age to 0. We inserted a few records to the customers table, and purposely we inserted some negative age records, and then we converted this age records to 0. Then we learned how an after insert trigger works. So we created two tables, customers 1 and message. So wherever the customer's date of birth was missing, we passed in a message saying, hi, the name of the customer, please update your date of birth. Alright, now moving ahead, we saw how before update trigger works, and finally we learned about before delete trigger. So in this video we will learn subqueries in SQL. We'll also have a look at stored procedures and learn about triggers in SQL. We'll cover views in SQL and look at some of the important Windows functions in SQL. Now to learn all of these, we'll be using the MySQL Workbench on Windows. So let's get started with subqueries in SQL. So let me head over to my MySQL Workbench. So currently I am on my MySQL Workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright, so this is my MySQL Workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright, so first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee. From my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, First, it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with 2 different tables. So suppose you want to display some information that are present in 2 different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is MySQL tutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using 2 tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, You see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay, so first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write ampersand ampersand. Next I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top underscore players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was double ampersand. Next I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter, and there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top underscore players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top underscore player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top underscore players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL underscore IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records, so I'm using this limit keyword and my variable var, which I created here. I'll end my select statement. I'll end my stored procedure with / and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is sp_sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is sp_sort by salary. The other two were top_player and top_players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is sp_sort by salary. And inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now, instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /. Then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in two parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says one row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay. So suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore EMPs, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter to / I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female, I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp underscore details. So I've used my out parameter and I'm creating a new variable called total underscore EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I'm storing it in total underscore EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure, sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets, I'll pass in the parameter as @f underscore emp. I'll give a semicolon. Then I'll write select @f underscore emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure, and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now, there are mainly three types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting if any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. age is 13, the name is Dave, and let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay. Now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name which is cust underscore details. Then you write as select. I'm going to select a few column names from my original customer table which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright, I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view I can write select star from followed by the view name that is cust underscore details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that I'm going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside classic models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there's some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product underscore description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table, I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay, now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cust details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be Okay, so instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that, you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright. Now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay. I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright. Now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num. I'll give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name. which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name 102. The name is Bradley. I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over within brackets. I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane. We have one student in the name Bradley, but here if you see for Herath, the second record it says 2, which means there are two records for Herath, and if I scroll down there is one record for Nathan and there are two records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when two or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable that is var underscore a as an alias name, let's say test rank, from my table that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function has assigned the same value which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column that is salary descending. I'll give an alias as highest underscore salary from my table that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function that is first underscore value followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial So let me just scroll through and show you what we did from the beginning. First, we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database, which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL, which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions.
So SQL subqueries. So subqueries in SQL are majorly of three types, which are scalar subqueries, multi-row subqueries, and nested subqueries in SQL. So when it comes to scalar subqueries, it'll return one row and one column. And when it comes to multi-row subqueries, there are two types. It can either give you one column and multiple rows, or multiple columns and multiple rows. And the last one is almost kind of self-explanatory, which says it is just a subquery inside an already existing subquery, right? So without further delay, let's get started with the MySQL Workbench, load our dataset to the MySQL Workbench, and try to query some subqueries based on the use cases that we are able to build on the dataset that we are using, right? And you can, this might be an interview question, so where exactly can you use a subquery? So you can use a subquery along with the where, along with having, along with between, along with a select query, maybe insert, right? There are multiple possibilities. Just try to name a couple of them, maybe a 4 or 5, which makes you stand on the safer point during your interview. Now, let's get started with the MySQL Workbench. Now, here we are. The first thing that we will be doing is load the dataset. So just click on this new schema. So new schema is nothing different from your new dataset. So let's name it as Superstore and apply. It requires lowercase. So let's proceed with the lowercase as well. Not a problem. There you go. You have the new dataset or database. Now you need the dataset. So that dataset needs to be applied to the table. So currently we don't have any data in the table. Go to the import data wizard, browse, and downloads, and here somewhere I have SQL data. And remember to save your Excel data in the form of the comma separated file as CSV, and ensure that all your data table name and the column headers are compatible with MySQL or SQL. So basically what's the problem is, let's say you have some maybe the difference in naming convention, row space ID, right? So that could cause a problem when you are kind of trying to write a statement, right? So here I've already done that, row ID, order ID, order date. So I've replaced with an underscore wherever I found a space so that it becomes automatically SQL compatible, right? Now the first row might be having a small error due to the import function, but that's something that we can fix. So let's also check other column names or column headers over here. So every other column header looks absolutely fine, but the first one, which happens to be a small import error, but that's something we can fix. So go to the next and press on next. So this is about 9,000 to 10,000 rows of data, which might take a little while, but that's not a problem. Let's wait gently. There you go. The data got successfully imported. Now the next step is just click on the next here. And yeah, therefore we have our 9,987 records imported successfully. Finish that, and we can close this schema. And now refresh the dataset here. Just right click and refresh all. And there you go. You can see the arrow mark here. Just click on that. You can see the Excel dataset. So here we have all the columns and remaining things what we require. So here are the columns. Now let's quickly use the dataset. The dataset name is Superstore. So this is the Superstore dataset. So we have also named the database as Superstore. Just run it. Now we have the full access of Superstore. Now you can just run the select star from the table name as Excel data, and we have query ready, and just run it, and we have the entire table right here. Yeah, so remember we were supposed to change the row name, right? So you just hover over this, and I think you'll get an option of copying the field name. Copy the field name. Now use the alt table Excel data, rename column to row. Go. So we have done it. You can just run this query once again and make sure that everything is fine. There you go, row ID. So far so good. Now let's get started with the subqueries. So as we discussed before, there are 3 different types of subqueries. Basically, scalar subquery, multi-row subquery, and nested subquery. So let's start with the scalar subquery. So there you go. Now we know scalar subquery will give us 1 row and 1 column. So according to that, let's try to devise a use case. So let's find out the list of customer names that made a purchase above an actual average, right? Let's say we have the customer names and customer IDs. Let us say that, okay, let's find out the average sale, the overall sale, right? So there might be a few customers who might have basically some deep pockets, basically they're rich, and they might have, purchased some goods from the store, billing more than the average of overall sales, right? We need to find out such customers so that we can basically offer them some discounts and maybe a few more coupons, something like that, so that encourage them to shop a bit more. That sounds like a use case, right? So let's get ahead with that. Let's write the use case. So that's our use case right there. So first we need to find out the average of all the sales. So let's write the query. You write the query by select and an aggregate function, which is average, AVG, sales. So we have sales data here from table. Let's copy the table name, Excel data, semicolon. So this is our first query, or you can also call it as an inner query. So the average sales is about $294, right? So this is our average sale. Now we need to use this inner query. We need to devise this as an inner query and write an external query where we will find out the customer names, right? So let's write that. Select customer name, customer underscore name from Excel data. So you can see that I'm using the naming conventions in a different way. The keywords are all caps, and the table names and the column names are in small, right? So this makes things easier for anyone who's reading your code. So they'll understand that this is, a variable name or maybe a keyword. So they'll easily identify that. So this happens to be our outer query. So select customer name from Excel data where sales are greater than average of sales. This is our inner query. So you can name it as outer query, and we have already named it. No, we didn't, but we can name it as inner query. So this increases the readability of your code, right? So now if we execute this, we can get the output. So we have so many names here, but we happen to require, as we can see, we have duplicate entries of data, right? So we can make minor changes over here. What we can basically do is use a group by function, and let's group them by customer names. And as a fact, we know the sale number, right? So let's include sales as well, so that we have customer name right in front of the sales, what they made, and we can have a clarification if they cross this 294 number, correct? And since we're using group by, and in that situation, let's replace where with having. Now this is the correct query. So that's the explanation, right? So you can use subqueries along with have, along with where, along with having, and select, right? So let's try to execute this code, and we should be having the output ready, right? So we have our customers, and they have made multiple sales here, right? So they might have come to the store multiple times, and they might have made multiple sales, right? So here they have made multiple sales which are above the given sales number. Now let's proceed with the next query, which is the type of query is multiple row subquery, the second type of subquery, right? So let's rename this as multiple row subquery. So why am I doing this? So this document will be an open source document, so that you can have access to this document while you are learning. This will be linked in the description box below. You can just download the dataset, you can just download the query document and try to follow us for a better learning experience. Now let's go with the problem statement for this. So it is something which gives you multiple rows and multiple columns in return. So now let's try to build a use case for this. So the use case is, let's try to find out, okay, let's execute our first query over here. So we have city, right? We have city, state. So now let's try to find out that particular state which has highest sales, right? So let's try to identify any state which has more than 100 sales. Let's say your manager just gave you a use case to find out that single state where we have maximum sales happening. So the sales number should be nothing less to 100, so that we can target the product more, right? So for that particular situation, we can go with this particular solution. So again, there are two parts of this, and firstly we will try to find out distinct states names, right? Select state from Excel data where sales is greater than $100 close. So this is the inner query. Let's execute this. So these are the states. Now we wanted a distinct allocation, right? So let's try to roll this state under distinct function, so that we have those distinct states. So one state might have faced multiple sales which are above $100, right? So we just wanted to know which are those states which are giving sales at least above $100. So that's the inner query. Now let's try to wrap it under an outer query, where we will try to find out the same thing. And we can do one better. So what we can do is, since we already had multiple states in the list, let's try to find out a city or state that has less than $100, right? So why don't we do that? Let's select distinct states or state from Excel data where state is not in, where state is not in, where state not in is not required over here. And you can open the bracket and you can wrap this inside an inner query. Close this. There you go. And if in case you wanted to provide some indentation, you can also do that. And your query is done. Now if we execute, we can find out those states which are not yielding at least 100 sales. There you go. So we have a list of 4 states which are not even giving us 100 sales, right? So in these sales, you can do two things: either stop your store, or you can give some exciting discounts on your products, so that you can drive some motivation in the customers to buy some things. Now the next use case is, let's try to find out some product names from subcategories that get higher sales than all the products in their subcategory, right? So this is another example in multiple row subquery. So let's try to execute that. Let's write down the use case first. So we have the use case ready. Now let's try to write the query. Select product name. Let's also try to extract the subquery, right? That should be helpful. Subcategory, not a subquery. Maybe we can also extract sales numbers from Excel data. And let's try to alias them as E1, where sales is greater than, so this is the outer query, Now let's try to build the inner query. Select average of sales. We wanted to find out that product which is selling more than the average of all the sales, right? Sales, wrap it under the average function. From Excel data, we can alias it as E2. So why am I doing this aliases over here? Because there is a funny thing, not actually funny. So this is an important thing which you might have to consider, because these aliases will help us to write a query in such a way that the query will run only when it has some value from the outer query. So far here, if you run this query, the inner query, it will actually run without any error. And when you execute it along with the outer query, it will run, right? But in the current situation, the current query which we are writing here, it will not run unless it is clubbed with the outer query. How? Let's check it. So I'm going to write a where query right next to this, where E1 dot subcategory is equals to E2 dot subcategory. You can just copy paste this to save time in the interest of time and close the bracket, right? Now, if you try to execute this inner query, it will never execute. It will throw an error, right? Now, if you club this along with the external query, it will run. So if the query is heavy, sometimes we might lose the connection to the data set or the server. It's okay. At times we can just optimize the query and try to get an alternate result. So you can see it's running over here, fetching. We should be receiving the output shortly. There you go. We have the data. So based on that particular subcategory, we have accessories, we have labels, appliances, right? So it's like you are grouping all the categories available in your dataset and you're calculating the average of sales happened in that particular subcategory. Now you have that average number, right? And if any product in that subcategory is selling above the average of that particular subcategory, we are extracting that product name, right? So SanDisk, numeric keypad, Bluetooth. So these are some products which are outselling in those respective categories. So we're basically trying to find out the best performing products of all the individual categories, right? Now let's proceed with the next query. Let's proceed with our third type of subquery, which happens to be the nested subquery, right? Now let's devise a use case for this. So the use case is find the customers who have placed orders for products from specific category and whose total sales exceeded the average sales of all the customers and who have placed orders for products from the same category, right? So this is the use case. Now we can devise a solution in 5 steps, as I have mentioned already here. Identify the customers who have placed orders for products from specific category. That's the first step. Then for each of these customers, calculate total sales for products from the specified category. And then calculate the average sales of all customers who have placed orders for products from the same category. Fourth step is compare the total sales of each customer from step 2 with the average total sales from steps 3. And lastly, return the list of customers whose total sales exceeded average of all sales. Now, this is a little complex to understand, but again, not to worry about. We will devise the solution one step at a time, right? So we will write the query inside a query inside a query, right? So we will be also using some join clauses in between. So that's how it's going to work. So let's quickly write the query. So the first query that I'm going to write is find the customers, identify the customers who have placed the orders for products in specified category. So select customer ID. Let's also try to calculate the sum of sales that they provided. Sum of sales. And let's call it as an alias as total sales, right? So far so good. Okay, let's try to add an underscore. I missed that. Excel data. So the thing is, for a specified category, right? For a specific category. So the query is a little interesting here. So, okay, let's quickly run our query here where we will identify what categories we have, right? So, select category from Excel data, right? So, we will identify which categories we have. So, we have office supplies, technology. Okay, let's try to identify it as a distinct so that we have the unique names of our categories. So now we have the unique names of our categories. We overall have 3 categories. Now the use case is they want to find out the sales from a specific category. Right, now let's provide the category as, I don't know, I like technology. So let's try to add the specific category as technology. From Excel data, where category is equals to, remember the double quotes or single quotes because we are dealing with character type data type. So technology, or you can just copy field, right? So we don't want to take any risks here. That's the first query. Close and try to execute. Yeah, we missed group by, so what you can do is just add a group by. Let's group by customer ID. There you go. So based on the customer ID, we have grouped it. Now this would be our inner query, and before we close it, we will alias it as customer sales. Okay, that should be the good name for it. So close this using a bracket, and also begin this using a bracket, and name it as customer sales. There you go. So the first part of it is done. Now we are going to implement the join function. Now based on what are you going to join this, we will be using the same query. We will be making a mild modification onto it. E1 dot customer ID. Let's copy paste. And this E1 dot customer ID should be equals to customer sales dot customer ID. So far so good. Join. We will copy paste the same query over here. This should be our inner query, and the outer query, try to select average of total sales, average sales from, and try to make some indentations so that it's easily readable and understandable. So I don't think we will be needing the customer ID here. All we need is sum of sales. We will name it as total sales from Excel data, where we have the category. Okay, we have grouped it, and now let's close it and alias it as average sales. Okay, on customer sales. Okay, we will join this on customer sales dot total sales, and this should be greater than the average sales of that particular category. Sales dot average sales. So far so good. Now we have devised the inner query and outer query. Now we need to take care of what are we going to extract from this, right? Now we want to extract distinct names. Okay, this might give us a lot of names, so we want distinct names, distinct of E1 dot customer ID, comma E1 dot customer name as well. So let's go with customer ID and remove ID and type down name, and we are extracting this from Excel data. Let's alias this as E1. This is our E1 table. Okay, and now we are going to join this. SQL databases provide robustness and consistency through structured data schemes, ideal for complex queries and transactions. On the other hand, the NoSQL databases. So they offer flexibility and scalability by ensuring the structured approach of SQL databases, allowing for easier management of unstructured data. Now it's obvious that both these platforms have a huge demand for their specific needs and requirements. Now the major question for today's session is, which one of these two has the higher demand and best suitable for most of the use cases? and what are the critical differences between the both, and which one of these differences that you need to discuss and consider before getting started with a SQL-based project, right? So that's it. Let's get started by understanding each one of these and popular database management tools and the critical differences between the both. Starting with the agenda for today's session. Firstly, we will discuss major companies which are dependent on SQL developers and which are actively hiring SQL as well as NoSQL developers. Next, we will discuss the salaries offered to a certified SQL and NoSQL developer. And after that, we will understand what exactly is SQL, then the popular SQL databases. Followed by that, we will understand what is NoSQL with a brief introduction to both. And then what are the popular NoSQL databases which are being currently used in the IT industry. And next, we will close with the most important part of today's session, which happens to be the critical differences between the both SQL and NoSQL databases. Having said that, I hope I made myself clear with the agenda. Now let's proceed with the companies hiring SQL and NoSQL developers. Now, SQL and NoSQL databases are the most popular databases which are currently actively used in the IT industry. Some of the major companies, product-based companies or service-based companies which are dependent on SQL and NoSQL databases are as follows. Majorly, the MANG, the Big Four, and many more like PepsiCo, Accenture, Wells Fargo, Capgemini, Netflix, and many more like IBM, Walmart are solely dependent on database management systems. And these are the companies which are ready to pay huge compensation for the certified developers who know SQL or NoSQL. Now, let's also discuss about the huge paychecks they're offering to the certified developers in SQL and NoSQL. So, if you are in America and if you know database management, then they are ready to offer you the salaries from $90,000 to $100,000 per annum if you are a beginner. And if you're an intermediate candidate, let's say with about 1 to 2 years of experience, you can expect salaries ranging from $100,000 to $110,000 per annum. And if you are an experienced, highly experienced candidate with about 4 or 5 or more experience, then you can expect salaries ranging from $120,000 to $130,000 or even more based on the company you're working with and on the project you're working for. And if you're in India and if you're a beginner in SQL development or NoSQL development, ranging from 3 lakhs to 6 lakhs per annum, and if you're an intermediate candidate, let's say 2 to 3 years of experience, you can expect salaries ranging from 6 lakhs to 8 lakhs per annum. And if you're a highly experienced candidate, let's say more than 5 years of experience, you can expect around 8 lakhs to 12 lakhs per annum as a minimum or average salary. And the number can go as high as 40 lakhs, 50 lakhs per annum based on the company you're working with or based on the technology, let's say like Oracle, etc., or on the project you're working for, right? So based on that, your number can go as high as 35 to 40 lakhs per annum. So that's the importance of SQL. So it's a good time for you to get certified as a SQL developer or a NoSQL developer. Now, let's proceed with the next part of today's session where we will be understanding what exactly is SQL. So, what is SQL? So, there are many definitions to SQL. Some say it is a tool, some say it is a programming language. But as a full form for it, SQL stands as an abbreviation for structured query language, majorly proving that it is basically a language. Now, it is a domain-specific language used to manage data, especially. So, we have DML, DDL, right? So, especially related to database management system. It is helpful for handling structured data by incorporating relationships among the entities, what we call also as tables, right? So primary key, foreign key, using which you can establish a successful relation between them and try to join both the tables and extract data. Now let's also discuss some of the features of these SQL data tables. So SQL will help you keep track of your transactions, and SQL will help you with data loading from different sources. Apart from that, SQL offers top-notch security, and then it also helps you with data transformation and user-friendly user interfaces. Now, we have a brief understanding of what exactly is SQL. Now, let's proceed with understanding some popular SQL databases which are currently being used in the IT sector. So some of the popular databases of SQL that are actively used in the IT sector are Oracle, MongoDB, PostgreSQL, Microsoft SQL Server, Azure, Redis, Elasticsearch, MySQL, and many more. Now let's proceed with what exactly is NoSQL. So there are many concepts of NoSQL. Some say it is NoSQL, or some others say that it is not only SQL, meaning it can perform more than what just SQL can do, right? So the definition that we have for NoSQL is an approach to database design that focuses on providing a mechanism for storage and retrieval of data that is modeled in means of other than tabular relationships used in relational databases. So as we said that SQL can manage data which is only present in data tables under named columns and rows, right? Apart from that, we cannot do anything. But in SQL, you can rely on that for handling non-structured or unstructured data as well. Apart from just handling the data tables, it can do a lot more than that. It can also help you manage the non-structured or unstructured data, like media, photos, and everything. Now let's also understand some of the popular features of NoSQL. So NoSQL databases are easily scalable, and you can expect high performance through NoSQL databases. And similar to SQL, NoSQL is also capable of offering high-end security, and replication of data or shifting data from one place to another is also very easy using NoSQL. And lastly, NoSQL databases can be updated very easily without any hassle. Now, let's proceed with understanding some of the popular databases based on NoSQL platform. So, some of the popular NoSQL databases are RavenDB, MongoDB. Yes, MongoDB can also work with SQL as well as NoSQL. Followed by that, we have Apache Cassandra, one of the popular databases created by Facebook. And next we have DynamoDB from Amazon, CouchDB, Apache HBase, which is also from Apache, and Neo4j, and also Redis. Now that we have a comfortable understanding of what exactly is a NoSQL database, its features, and some popular databases which are currently being used in the IT industry, so we have a comfortable understanding of both SQL as well as NoSQL databases. Now calls for the major part of today's session, which is the critical differences between SQL versus NoSQL. So the first difference. So as we discussed, SQL deals with named columns and rows, and the data is stored in a tabular form like an Excel spreadsheet. So SQL supports the relational database management system. On the other hand, NoSQL supports both relational as well as it can support non-relational database management system. So basically, it tries to function on the fundamentals of non-relational database management system. Now, the second point of difference is data storage. So SQL chooses to store data under named rows and columns in a table format. On the other hand, NoSQL prefers to store data in the form of collections and documents. So what are collections and documents in NoSQL as? So those are just some interchangeable data formats which are human and machine readable. So those are the files which store data in the form of JSON and BSON formats which are readable by machine and humans. Now, let's proceed with the third point of discussion. So the point 3 is SQL follows asset properties, but NoSQL will not or maybe need not to follow asset properties. So what are asset properties in SQL? So basically, asset is an full form for atomicity, consistency, and isolation and durability. So first, let's understand what is A. A is atomicity, where each statement is a transaction, right? And it is treated as a single unit. Either the entire statement is executed or none of them is executed. Next, consistency, ensuring that the transactions only made changes to the tables in a predefined and predictable ways. Transaction consistency ensures that corruption or errors in your data do not create unintended consequences for the integrity of your table. Next one is I, isolation. So when multiple users are reading or writing from the same table all at once, isolation of their transactions ensures that the concurrent transactions do not interfere or affect one another. Now the last one, D for durability, ensures that changes to your data made by successfully executed transactions will be saved even in the event of system failure. So these are the asset properties which SQL abides and follows, but NoSQL may or may not or need not to follow these asset properties. Now the fourth point, which is about the complex joins and queries. Now SQL supports the types of joins, maybe the inner join, outer join, left join, outer join, and cross join, etc. And it can also support some complex queries like CTE and subqueries, etc. But NoSQL, on the other hand, does not support these joins and complex queries. Now, the last point of today's discussion between both. So SQL is dependent on vertical scaling and NoSQL is dependent on horizontal scaling. Now, what is vertical scaling and horizontal scaling? So let's say you have a database and you are managing some website or something like that, and you have a bunch of requests which are additional requests on your current request. Let's say you have 100 requests today, and tomorrow you're expecting to have about 120 queries, right? In such scenario, if you are using a NoSQL database, then you can just expand the network. Let's say you have 5 bases today to handle those 100 requests, and tomorrow you have additional 20, right? In such scenario, what you do is just add a NoSQL database, one extra. We will be having one more dedicated for that extra 20 queries. That's called horizontal scaling. Just add another database to your existing network. But on the other hand, when you come to SQL, it is dependent on vertical scaling. Let's say you are having just one database to handle 100 queries, and tomorrow you get an additional 40 or 50 queries. In such scenario, you cannot just add an extra database. What you have to do is you may have to add some extra juice to your server, right? Let's say your server or database can have about 100 GB of processing capability. You need to increase that processing capability to 150 GB. Basically, you're upgrading your hardware. You're not just adding more hardware, you're upgrading it. In such scenario, it is mentioned or it is called as vertical scaling. So SQL is dependent on vertical scaling and NoSQL is dependent on horizontal scaling for additional requests. So these are the top 5 differences between SQL and NoSQL. So before you get started with a database project, these are the 5 differences that you need to consider and understand and proceed with your project. We will learn about the top 5 interview questions in SQL that you must know to crack your business analytics interviews. Now, without further ado, let's get started. So speaking about the top 5 interview questions, let's quickly jump to the Workbench of SQL. So I'm using MySQL Workbench, and here we have a database called Use Simplilearn. So SLP is the database name. So we'll be using the use command to get access to that particular database. So we are in access to it. And now let's quickly check our tables. Show tables. There you go. We have a few tables here: book collection, book order, employee details, joining register, and employee register. So let's go with the employee details. So I'll just simply shoot a command, select star from emp details. So now we have our employee table. So we will be using this particular data set to run few queries from our interview questions. So getting back to the interview questions. So most commonly you will be asked the following interview questions. So the first question is, you will be asked to find out the names of the employees that start with the vowels. So A, E, I, O, U. So they will ask a question, give me the list of names that start with these 5 letters. It can be either A or E or I, O, U, right? So what's the question? So here you will be using like operators and not like operators. Let's say they want the names with vowels. So you can just use the like operator and use this particular command. Select employee name, that's the name of the column, from employee register or employee details, and then where employee name is like A modulus, which means it should start with A and it can have any number of alphabets after that, right? So let's quickly also check what do we have in employee register. So I think it's a similar table to employee details that we used before. We have the same details here, so no problem. Now let's try to extract the names of the employees whose names start with vowels, right? So we will be using the where clause and like operators. Run the command and there you go. So we have 3 names. So if you are able to answer this question, they might ask a similar question with a little modification. So this time they might ask you, give me the list of names that will not start with vowels. So you'll just replace the like operator with not like. So either they'll ask the questions which might start with vowels, or they might ask a question which does not start with vowels. This is one of the common questions. Now going to the second question. So here also they will give it a simple start. They will ask to give the details of the employee who has the highest salary, or they will ask you to give the highest salary. You can simply use the max aggregation and you can get the maximum salary. So we have $87,000. And sometimes if you are able to answer this question, they will make it a little tricky to you and they will ask, give the second highest salary. Here you can use offset, or there are multiple possibilities, but let me give you the simplest one where you can have the same query. Only difference is where salary is less than max of salary. First, the subquery will be executed which will extract the maximum salary, and the next one is less than. So it will give you only one row which has a little salary which is less than the maximum one, right? So simply let's execute the query. So we will have the answer. So the next highest salary is $78,000. Now moving on to the third question. So sometimes they will ask you to use the update commands as well. So here we have some salary details of our employees in the employee register. What I'm going to do here is, let's say this is the appraisal period and they're giving you 15% hike to all the employees. So you need to update the salary column. So what you do is simply update table name salary plus salary into the percentage of hike, which is 15%. So here we are adding that particular percentage in the form of decimal numbers, which is 0.15, and simply run the command and you have it. Now you can just simply query the same detail, which is select star from employee details. So you will have the updated salary list here. There you go. Now let's proceed with the next question that we have in our list, which is about select the employee name and salary from a given range, right? If they ask you, give me only the range of employees whose salary lies between 50,000 to 70,000. So you can use the between operator here and range of numbers, that is 50,000 and 70,000. Just run this particular code and there you go. You have the details. So there are 2 employees whose salary lies between 50,000 and 70,000. Now the last question is, they might ask you to extract the details from a certain department. So basically, this might also turn up to find a difference between having and group by clause. Having and where clause. Yeah. So this is one of the common interview questions where they will ask the difference between having and where clause. So when you are implementing group by in your query and you're also implementing some aggregate functions like count, sum, etc., minimum, maximum, in those situations when a group by clause is involved, then you can use having. When there is no group by function, then you can simply go with the where clause. So here I'm trying to extract the number of people present in finance department. So I'm not grouping by department, so I can just use where clause and run this. And now in situations where I have to group by, when I have to implement group by, in those scenarios, you can include having clause in place of where. So that is the fundamental difference between having and group by. And also you got the understanding of group by command here.
With this, we have come to end of this full course. If you have any question or doubts, please feel free to ask in the comment section below. Our team of experts will help you as soon as possible. Thank you and keep learning with Simplilearn.